Hello everyone, I am Brandon Ordoñez from ECE 41 and today I will be performing our summative assessment number 1 for our robotics laboratory, which is entitled Sensor with Serial Communications. Hello everyone, so now let us begin with our experiment. So first, for the objectives, this experiment will enable the student to convert analog signal to digital value for the Arduino to process, to control the angular displacement of the robotic arm using the potentiometer, and to create a computer program user interface to display data coming from Arduino. So the third objective will be disregarded since we will no longer create a user interface for this experiment. So first, for the problem, it is to create a program for the microcontroller that will control the angular displacement of the servo motor connected in the robotic arm by using a potentiometer. The angle created by the potentiometer will be imitated by the robotic arm. So first, I will explain that this experiment or summative assessment is divided into two parts. So for the first part, we would display the results using serial monitor from our Arduino IDE, and for the second part, we would display the results using an LCD1602 module. So first, for part 1, where we would display using serial monitor, this would be our code. So these are the basic setup for this experiment. So I have included our servo library. Next, my servo creates a servo object to control a servo. Next, this would be the variables used for this experiment. Next, for the setup, serial begin, my servo attach 9, since we would be attaching our servo motor to pin 9 of our Arduino Uno, and a message would appear that says that I have created or I have edited the code provided for this experiment. So next, for the main void loop, first, value or val analog read pot pin reads the value of the potentiometer. So from here, our microprocessor would read the value that is given by our potentiometer. So whenever we turn it, it records a value. Next, this command scales the read value. So the value would be in angular form, which is from 0 to 180. Next, this would show us the value that is given by our potentiometer. And this one sets the servo position according to the scaled value. So this command enables our servo motor to move. And then this would be the message that would appear at our serial monitor later when we upload the sketch of our Arduino. And this would be the delay, meaning that let's decrease it to 20. This would be the delay that would tell us how long would our microcontroller read again after this certain duration. So it would be every 20 milliseconds. So after every 20 milliseconds, our microcontroller would read the value of the given by the potentiometer. So next, this would be our proposed circuit assembly. So this is our potentiometer and this is our servo motor. So both are connected to the 5-volt terminal of our Arduino Uno. Next, this would be the ground terminal of our servo motor and our potentiometer, which are both connected to the ground terminal of our Arduino Uno. Next, for the output of our potentiometer, it is accepted by the analog input 0 of our Arduino Uno. And lastly, the yellow wire or the pin, the last pin of our servo motor is connected to pin 9 of our Arduino Uno, which is the output. From here, we would be able to see the angle or the angular movement of our servo motor. So next, this is the schematic diagram for the proposed circuit assembly. It just says the same that one side of our potentiometer and our servo motor is connected to the ground. Next, the servo motor, shown by the red line, and the potentiometer are both connected to the 5V terminal of our Arduino Uno. And next, this would be the last pin or the output pin of our potentiometer, which is connected to analog pin 0. And this would be our output pin for our servo motor. So this would be our input pin and this would be our output pin. So for the output pin, it is connected to pin 9 as shown earlier. And from here, you'll be able to see the movement of our servo motor. So now let us see and observe the effects of our circuit when we run it and we upload our sketch. Hello everyone, so now I have uploaded our sketch and we will now try to fill out our table for part 1 of our experiment. So first, let's go to our serial monitor. There, and let's record. So first, for 0, for a servo angle of 0, our potentiometer value is also 0. Next, for a servo angle of 20, our potentiometer value is 116. Next, for a servo angle of 40, our potentiometer value is 228. Next, for a servo angle of 60, our potentiometer value is 349. Next, for a servo angle of 80, our potentiometer value is 463. Next, for a servo angle of 100, our potentiometer value is 578. Next, for a servo angle of 120, our potentiometer value is 694. Next, for a servo angle of 140, our potentiometer value is 803. Next, for a servo angle of 160, our potentiometer value is 921. Lastly, I'll just pick the highest value since I cannot turn it to 180. So for a servo angle of 179, our potentiometer value is 1022. So we'll place it in place of 180. So next, this would be the second part of our experiment. So this would be the code for the second part of our experiment. So I have included a liquid crystal underscore I2C library. I have downloaded it from Arduino's website. So this creates servo object to control the servo my servo. Next, liquid crystal underscore I2C LCD is equal to liquid crystal underscore I2C 0x27 16.2. This just states that that we would be using a 16x2 LCD screen for this part. Next, this would be the integers, the variables used for this part of the experiment. So my servo attach 9, we're still using pin 9 for this experiment, attaches the servo on pin 9 to the servo object. Next, LCD.init initializes the LCD display, LCD begin. Next, backlight, this triggers the backlight for our LCD. Next, a message would appear at the beginning of serial monitor. So next, for the main loop, this is just the same explanation with earlier, wherein the microcontroller derives the value of the angle for our servo motor and also the value given out by our potentiometer. So I have included this part in order to so that the data would still appear in our serial monitor, and this part of the sketch enables us to see the values from our LCD display. So again, there would be a refresh rate for the values of 20 milliseconds. So every 20 milliseconds, the microcontroller would read the value given out by our potentiometer, as well as convert it into its respective angle for our servo motor. So this just clears the display every 20 milliseconds. So that's it. So now this is our proposed circuit assembly for this part of the experiment. Same with earlier, we have just added an LCD display which is connected to the ground terminal of our Arduino Uno, as well as a VCC which is connected to the 5V terminal. Next, the SDA is connected to analog pin 4, and SCL is connected to analog pin 5. So this is the schematic. It is the same with earlier, except with the addition of our LCD display, which is also which has a connection to the ground and to our 5V terminal, as well as the SDA connected to analog pin 4 and our SCL connected to analog pin 5. So now now I will upload our sketch to our Arduino Uno. So it is now done uploading, and now let us observe the values through our LCD display. So now let us begin by first getting the smallest value for our potentiometer. So as we could see, the data is displayed from our LCD display instead of our serial monitor. We can also view it at our serial monitor, but we have already done that on our first part. So now let us begin. So first, with a servo angle of 0, the potentiometer value is 3. Next, let's increase. So at 20, the potentiometer value is 119. Next, 40. There. At 40, the potentiometer value is 230, sorry. Next, at 60, the potentiometer value is 343. So at 60, at a servo angle of 60 degrees, our potentiometer value is 343. Next, here. At 80, at a servo angle of 80, our potentiometer value is 461. Next, at 100, at 100, at a servo motor angle of 100, our potentiometer value is 574. Next, at 120. Here. At a servo angle of 120, our potentiometer value is 688. Next, at 140. At a servo angle of 140, our potentiometer value is 804. Next, at 160. So at a servo angle of 160 degrees, our potentiometer value is at 919. Next, at a servo angle of 180. So this is the highest value possible since our potentiometer is maxed out. The potentiometer value is 1020. So for the proceeding part of our experiment, I will show the comparison of our gathered data. So I have created a chart for us to easily compare the potentiometer readings from our serial monitor and our LCD display. So from here we could see that both lines, the blue line is for the serial monitor and the orange line is for the LCD display. Both lines yielded close results. That's why they're almost overlapping each other. So from that we could say that the readings are precise but not accurate since the values are close to each other upon gathering the data that we have performed in this experiment. So in conclusion, we could say that we we could say that both readings are precise and can be used in reading the potentiometer values given out from our circuit.
You getting high already? It's just 2 o'clock.
Is that late?
You know you smoke too much of that shit. That shit's gonna rob you of your ambition.
Not if your ambition is to get high and watch TV.
Ain't no time for faking jacks. Stop faking jacks. Brothers who fake jacks get